The topic I selected is the last Yellowstone explosion. To meaningfully discuss this topic, I have decided to organize my report around four geologic questions. Namely, what type of geological formation is Yellowstone exactly? What geologic forces created it? What is Yellowstone's explosive history? And beyond simply examining these explosive events, how have the forces at work in Yellowstone impacted the surrounding environment, its topography, climate, soils, and vegetation? And why is it called Yellowstone? Exactly what type of a geologic formation is Yellowstone? Well, it's a volcano, though it certainly doesn't have the conical or mountain-like shape we may typically associate with volcanoes. According to the Oregon State University's extensive Volcano World website, there is no universally accepted classification system for volcanoes. Yet there are ways geologists and other scientists use to describe them. My examination of this and a number of other sources has convinced me that the best way to describe Yellowstone is as a rhyolite caldera complex. And here's what these three words mean and why they matter. Rhyolite refers to the type of rock that extrudes from the volcano, rhyolite being one of the four major types of lava. It is an extrusive rock whose chemistry is rich in silica, aluminum, potassium, calcium content, and that forms feldspar and quartz, similar to granite but with smaller grain size, resulting in a much lighter weight. Rhyolite is typically a high viscous polymer-like substance that's thick and sticky, sometimes described as being like toothpaste coming out of a tube, forming a big lava dome. And yet, at the super high temperatures, it can also flow over many tens of thousands of kilometers, as is the case in the Yellowstone Snake River Plain. A caldera refers to the enormous crater-like formation that results when the eruption is so explosive that it collapses on itself, or what one of the world's foremost volcanologists, George Walker, called inverse volcanoes. Some geologists categorize volcanoes by simply something called the Volcano Explosivity Index, or VEI, based on how much it emits when it explodes and the height of the eruption. On that scale, from 0 to 8, Yellowstone rates an 8 in the category of supervolcanoes, giants that eject and deposit more than 1,000 cubic kilometers, or 240 cubic miles, of magma. Imagine a plot the size of the city of Chicago, but a full mile deep, and that's the minimum volume necessary to rate an 8 as a supervolcano. And because Yellowstone is made of rhyolite, which is very porous and lightweight, its eruptions cannot form tall cone-like structures, and rather they crater and form an enormous caldera. And finally, complex refers to the structure of this kind of formation. Yellowstone isn't just a simple vent in the ground spewing magma and ash. Rather, it sits atop a highly complex combination of hotspots below the surface that create some of the most interesting landscape features above. Steam vents of smaller eruptions around the ring of the larger caldera. Mud pots that look like boiling fudge. Predictable geysers and unpredictable ones, including Old Faithful, for example. Hot springs and sulfurous waters boiling up into pools, and other sightings that become attractions for tourists owing to their uniqueness and their rare appearance in nature. And so, Yellowstone is a rhyolite caldera complex type of volcano. What geological forces created Yellowstone? Well, there are three primarily geological forces that combine to create the Yellowstone caldera: volcanism, faulting, and uplift. These have been identified through numerous studies of Yellowstone conducted since the early 1870s, more recently with in-depth analyses of the geology, the ecosystems, biota, tectonic, and hydrothermic processes at work in the area, and even wide-angled photography of the caldera taken from space, giving us a full view of the caldera and its size that could only be described or imagined in the past. Volcanism is basically the process of accumulated molten rock under intense pressure that eventually erupts through the surface of the Earth. And geologists seem to agree that Yellowstone is the result of a hotspot, which they define roughly as a place on the Earth's surface that experiences volcanic activity over a long period of time. In this process, high-pressured eruptions from the Earth's mantle convect upward through the crust, creating something called a mantle plume. However, there's been some disagreement about where in the mantle this activity originates. deeply in the mantle, or in the upper mantle. And while the scientific discussions I found are way over my head, technically, it does appear that most of the recently accepted hypotheses are that the Yellowstone hot spade originates in the upper mantle, in fact, no deeper than 200 kilometers deep. The second primary force at work in Yellowstone is faulting. It occurs when the crust of the earth is stretched and then cracks or breaks, caused by plate tectonic forces. And in the case of Yellowstone Snake River Plain System, it is hypothesized that the tectonic plates are in motion over a mantle plume and that this faulting creates a vent for the plume. In the Yellowstone region, we see a type of faulting called basin and range faulting. This phenomenon created the mountains and valleys that are adjacent to the Yellowstone hotspot, including the Teton Range and Jackson Hole, Wyoming, for example. The third force, uplift, is pretty much what it sounds like, the vertical uplifting of the Earth's crust in response to natural phenomenon below, like volcanism, plate tectonics, and faulting. And over the past 5 million years, uplift in this region by as much as a kilometer or more than 3,000 feet of altitude, has created a steep valley wall and correspondingly deep valleys that are continually being eroded. Uplift has created stunning vistas of high-altitude terrain with deep valley rivers running through them, such as the Snake River and the Yellowstone River. And now that we know what Yellowstone is and what forces are at play, what is Yellowstone's explosive history? Based on decades of analysis of erupted material and layers of lava flows that are linked to the Yellowstone caldera, geologists have concluded that it has been erupting for at least 2.1 million years. Any possible evidence of eruptions older than that has been destroyed or buried by the material from eruptions since. In this period of just over 2 million years, Yellowstone has experienced 3 massive eruptions, rating at 8 on the scale I mentioned earlier, and each of these is separated from the one before it by around 600,000 to 800,000 years. The first and largest was 2.1 million years ago, estimated to have erupted 2,450 cubic kilometers of material, the equivalent of the land area of New York City, Los Angeles, Chicago, Kansas City, Missouri, and Kansas City, Kansas, and then taken a full mile deep. The second mega eruption, 1.3 million years ago, was considerably smaller, a little more than 1/10 of the size of the first. And finally, the third and most recent enormous eruption was around 640,000 years ago, spewing forth some 1,000 cubic kilometers of magma, about in the middle of the other two in size. In addition to lava and magma, these explosive eruptions spewed ash that completely covered the western half of the North American continent. And within hundreds of miles of the caldera, ash would have been more than a meter thick. Using new scientific models such as Ash 3D, which draws upon historic wind patterns to estimate thickness and distribution of ash, geologists suggest that if an explosive eruption were to occur at Yellowstone today, the entire continent would be covered with several inches of ash, bringing life as we know it to an end, or a standstill rather, and crop production would cease for a generation, and the planet would cool significantly for as much as a decade. But fortunately, no such eruption is imminent, as there's no evidence of sufficient accumulation of magma necessary to create such an eruption, or at least that's what most geologists seem to believe. Yet Yellowstone may not remain silent. In fact, in addition to these enormous eruptions, geologists have identified some 80 different lava flows that occurred from time to time in between these huge eruptions. The most recent such flow dated some 70,000 years ago, and for reference, that was during the latter part of the last ice age, at a time when the human population on Earth is estimated to have been only somewhere between 2,000 and 20,000 humans worldwide. How have the forces at work at Yellowstone impacted the surrounding environment, its topography, climate, soils, and vegetation? And why is it called Yellowstone? Well, clearly the forces that created the high-altitude terrain affect its climate, making the region conducive to weather patterns and snowfall one expects to see in such altitudes. Native Americans found the rocks in the area to contain high-quality glass-like obsidian, out of which they created many useful tools with razor-sharp edges. Rhyolite, the primary rock found at Yellowstone, tends to produce a soil that's sandy and contains little clay or nutrients. And because of this, Much of the plateau contains large forests of a single species of lodgepole pine, yet virtually nothing grows beneath them on the forest floor below, creating an almost desert-like ecology. In fact, more than 99% of this plateau is made up of just this one species of pine. In areas a few miles away where basalt is more prevalent than rhyolite, forests and grasslands thrive with diversity. And of course, we're all familiar with the many geologic rarities in the caldera: geysers, mud pots, and hot springs. Using helium isotope studies, geologists point to heat sources deep in the Earth's mantle as being responsible for these dramatic thermal features, the very features that led to Yellowstone becoming our first national park. However, Yellowstone didn't get its name from the vivid yellow and pink colored rhyolite lava that paints the park's Grand Canyon, marveled at by nearly 1 million visitors each year. Rather, the name Yellowstone derives from the yellow-colored sandstone, from a different geologic process entirely, that edges the banks of the river in eastern Montana, called the Yellowstone River, a few hundred miles downstream and well to the northeast of the caldera. The indigenous Hidatsa Sioux first named it something that loosely translates to Rock Yellow River. Then it was passed on to 18th century French trappers who called it Roche Jaune, and then was later translated into English as Yellowstone.